Okay, so the title of today's webinar is Building on a Strong Foundation, SiNAPS and OmniPlex Integration. And as I mentioned, we have Andrew Klein, the Vice President of Sales and Marketing, that will be doing this presentation. And most of you probably know Andrew. He has been at Plexon for a while. So Andrew received his bachelor's in neuroscience from Bowling Green State University in 2005. And then afterwards, he spent some time as a research associate at the University of Michigan. He then joined Plexon in 2008 in a sales role. And earlier this year, Andrew obtained an MBA from Southern Methodist University in Dallas. Overall, he has almost 20 years experience with in vivo electrophysiology data and animal behavioral analysis, and 15 years working with the neuroscience and biotech tools industry. So I'm excited for Andrew to present this information on the new SiNAPS system. And as I mentioned, there will be an opportunity for questions after Andrew is finished. If you think of something in the middle and you'd like to put that in the chat, go ahead and I'll moderate the question and answer session after Andrew is finished. All right, Andrew.
Okay. All right, so I think you should be able to see my my PowerPoint window. So let's get started. Thanks, Naoka. Today, I plan to talk about the latest updates to the Plexon OmniPlex system. There will be a lot of information shared here today. This webinar will be available offline on the Plexon website later. Please send us your questions for answering at the end of the webinar. Any questions or comments after the webinar concludes can be sent to me or to your specific Plexon point of contact. One important detail before we get started, I want to thank all the developers at Plexon for working diligently to devise, create, and deliver a high-quality, feature-rich, cutting-edge acquisition system, which I will talk about today. The SiNAPS OmniPlex project has been a long time in the works. This has been an all-hands project for Plexon. Thank you to Plexon's development team for staying the course and developing a competitive, complete system. Also, thank you to Plexon's sales and marketing team, and especially Naoka Burns and Alyssa Wright-Brown. Without their dedication and periodic nudges, this webinar would have never happened. Thank you, Naoka and Alyssa. With those important details out of the way, let's get started. So today's webinar will focus on the OmniPlex platform and the latest innovations involving the use of SiNAPS active probes with the OmniPlex system. We will review the OmniPlex platform. We will talk about SiNAPS and its specific technology. I have information to share about new features of OmniPlex hardware and software specific to SiNAPS probes. I will spend a little time talking about what is still in the pipeline for SiNAPS development from Plexon, and at the end there will be some time for questions and feedback. So to begin, OmniPlex started in 2009 with the OPX-A, or analog OmniPlex system. This first version of OmniPlex featured analog head stages, was limited to 128 channels, and acquisition occurred in a rack-mounted chassis well away from the electrode and animal. In 2012, Plexon released the DigiAmp version, which was similar to the OPX-A version, but with acquisition moved from the chassis to the amplifier, hence DigiAmp. Additionally, with the DigiAmp system, 512 channels of acquisition was possible, all with the same system, same amplifier, same chassis, same data file. Moving on to 2015, the Digital Head Stage Processor, or DHP, was released, which featured digital head stages. This version of the system enabled unique and novel head stage configurations, including Plexon's popular digital Samtec connector 64-channel and 128-channel head stages. This year, Plexon continues to innovate on the OmniPlex platform with the availability of the SiNAPS OmniPlex system. Today's webinar will focus on this new version of the OmniPlex system. Oops. Since 2009, Plexon has delivered hundreds of OmniPlex systems to labs all around the world. There are more than 1,000 peer-reviewed publications referencing OmniPlex systems. Simply put, the OmniPlex platform is popular. With all these users and all these publications, Plexon has learned the key features of the platform according to the user base to differentiate OmniPlex from everyone else. These differentiators include mature, feature-rich software. The latest system developments for use with SiNAPS probes requires the 21st release of the OmniPlex software suite. That is 21 times Plexon has updated the software to add functionality, support new technology, and address user feedback. OmniPlex software upgrades are free. OmniPlex software includes trend-setting spike sorting functionality, valuable referencing options, easy to use and manipulate data visualization tools, and the popular PL2 file format. On the hardware side, the OmniPlex platform features Plexon developed hardware based on 30 plus years of manufacturing high channel, timing accurate, easy to use, feature rich data acquisition systems. Lastly, Plexon's support and training are an important differentiating factor. Plexon's experienced sales and support team offers hands-on and virtual support and troubleshooting advice, and OmniPlex-specific training is offered in person, virtually, or in the Plexon office in Dallas, Texas. The in-office training is available for free, but those are all details specific to OmniPlex. What about SiNAPS? Why SiNAPS? So Plexon had several goals in mind when it decided to partner with the SiNAPS team and implement SiNAPS probe acquisition with OmniPlex. Firstly, it was about more channels. With SiNAPS and active probes, Plexon could achieve a greater than 512 channel acquisition system without adding dozens of costly, low channel count head stages. This was also a cost-effective method of increasing channel count. Doubling or tripling the channel count of OmniPlex by simply increasing the processing hardware is not cost-effective for the user nor Plexon. With OmniPlex and SiNAPS, a cost-effective method for high channel acquisition is now possible. Also, frankly, another goal was to remain competitive. With SiNAPS, Plexon can continue to set the industry standard for data acquisition systems and technology and remain competitive. Lastly, our users were asking about other active probes available on the market. A common question at SFN I get is, what is your plan for competing with NeuroPixels? SiNAPS is the way Plexon will continue to provide cutting-edge, high channel count data acquisition systems with a mature, high-touch supported and routinely updated platform. Based on features and functionality, the question now is, how does NeuroPixels plan to compete with Plexon? The answer is SiNAPS. SiNAPS stands for Simultaneous Neural Recording Active Pixel Sensor Technology. Simultaneous. Hence SiNAPS, not SiNAPS. The SiNAPS technology includes compact, high-density, high-channel electrodes with local front-end acquisition, which enables electrode configurations with the highest density possible on the market and a scalable number of recording sites. SiNAPS probes are available in 256, 512, and 1024 channel count configurations. The local front-end acquisition means high-channel active electrodes similar to others available today. But importantly, with SiNAPS and OmniPlex, acquisition is possible from all channels, not just a subset. So from the SiNAPS technology, new and different OmniPlex hardware is required. This new hardware can be broken into 4 different sections: the SiNAPS head stage, the SiNAPS adapter, the system tester unit, and the probe tester unit. Starting from the left, let's talk about the new head stage developed by Plexon for use with SiNAPS probes. The SiNAPS head stage is a Plexon developed piece of hardware that marries the probe to an interface accessible by the OmniPlex system. In the image are two SiNAPS head stages, one blue and one green, within a black 3D printed protective case. The probe can be seen in the foreground of the blue head stage. Here is a zoomed in version. The probe is bonded to the head stage, which includes a connector for OmniPlex system access. The head stages in this image are both acute head stages. There is a U-shaped piece of the head stage meant for attachment to a stereotaxic arm, hence an acute probe setup. The next piece of hardware is called the SiNAPS adapter. Here is a photo of the SiNAPS head stage. Here's a photo of the SiNAPS adapter attached to, here's a photo of the SiNAPS head stage attached to a SiNAPS adapter via a thin, short piece of amber colored flex. The SiNAPS adapter is the blue colored rectangle in the image. The SiNAPS adapter is the interface between the head stage and probe and the OmniPlex system. Among other things, the SiNAPS adapter is where the A to D step occurs. In addition to the SiNAPS adapter, the blue box for a SiNAPS system is externally similar to the standard digital head stage processor of other OmniPlex blue boxes, except that it has a single pair of ports with standard HDMI connectors. The head stage cable of previous OmniPlex systems is now replaced with a standard HDMI cable. The left side photo shows a SiNAPS DHP or blue box connected to a SiNAPS adapter via an HDMI cable. The right-hand photo shows a close-up image of the SiNAPS DHP input with SiNAPS adapter on top. The SiNAPS adapter is acquiring and processing the analog data from the SiNAPS probe. The blue box is providing the timing step and other critical processing information critical to OmniPlex acquisition. Next, there are two new tester unit devices for use with OmniPlex. The first, the system tester unit, available to the user to do just that, test the SiNAPS OmniPlex system. The system tester unit is similar to the traditional head stage tester unit offered by Plexon with traditional OmniPlex systems. This device is a new next generation head stage tester unit from Plexon and specific to the SiNAPS OmniPlex system. The system tester unit enables a user to feed up to 32 independent signals into a SiNAPS OmniPlex system via the SiNAPS adapter. The system tester unit includes its own software for creating playback files to feed into the SiNAPS OmniPlex system. The system tester unit is a valuable device for testing, troubleshooting, and demonstrating the functionality of the SiNAPS OmniPlex system. But SiNAPS probes are active probes, meaning testing the probe itself is much more complicated than traditional passive microwire or silicon-based probes. What about testing the SiNAPS probes itself with OmniPlex? For that, we have the probe tester unit. The probe tester unit is a device, a next generation device from Plexon and specific to the SiNAPS OmniPlex system. The probe tester unit will enable a user to feed a known signal into the SiNAPS OmniPlex system via the SiNAPS probe itself. The probe tester unit is a valuable device for testing and troubleshooting of the OmniPlex SiNAPS system. Together with the system tester unit, Plexon offers two new valuable tools for testing OmniPlex systems used with SiNAPS probes and testing the probes themselves. This is especially important for active electrode recording systems compared to standard passive electrode recording systems of the past. With these new tools, Plexon is offering a novel and valuable way to utilize SiNAPS probes and ensure successful recordings. With that, we have talked about 4 new hardware pieces available from Plexon for use with SiNAPS probes and OmniPlex. There are other pieces, but these are the critical pieces available today. From hardware, we move on to software. There are 4 new software-specific OmniPlex features developed for use with SiNAPS probes. These include online features with the OmniPlex software suite, as well as an offline data pathway for processing PL2 data files acquired from SiNAPS probes with OmniPlex. First, we will talk about auto calibration. Auto-calibration is a procedure which automatically optimizes the operating parameters of the SiNAPS probes for the highest signal quality and dynamic range. SiNAPS probes support both manual and automatic tuning or calibration of their DC operating bias to provide optimal signal headroom and quality. Probe tuning with OmniPlex is a two-step process. First, after one or more probes are implanted, the probe tissue interface is left to stabilize for a period of 20 minutes. Next, this auto-calibration procedure is executed in OmniPlex to perform the final tuning of the probe's bias, after which stable signals can be acquired and recorded. After the auto-calibration has completed, any channels which were unable to be satisfactorily calibrated will have their channel numbers shown in red in the multi-channel views within Plex Control. This is shown in the screenshot from Plex Control on the slide. Typically, very few channels will fail to calibrate. Next, we will talk about online spike culling. High-density neural probes like SiNAPS typically acquire action potentials from each cell on multiple adjacent electrode sites. This provides additional spatiotemporal information about each spike, such as the relative amplitudes and time offsets of the acquired spikes as a function of position relative to the channel where the spike amplitude is largest. On the right side of the slide is a schematic depiction of a single action potential as acquired on multiple electrodes, with the continuous data on the left side and the detected spikes in their relative position along the probe. The largest spike is shown in blue. Although this additional information can be very useful to offline sorters, which are designed to work with high-density probe data, OmniPlex employs a sorting paradigm where each unit is assumed to be acquired on a single channel. To support efficient online sorting of SiNAPS high-density data using any of the standard OmniPlex sorting methods, OmniPlex implements a culling procedure to reduce array spikes detected on adjacent channels to single-channel spikes as an additional processing step between thresholding and sorting. In this example, the black spikes would be culled out, while the blue spike would be passed through for sorting, visualization, and recording using any of the standard OmniPlex features, displays, etc. Next, we will talk about changes to the way users can select which types of data and which channels are saved into a PL2 data file. In the new version of OmniPlex software, wideband recording is enabled by default for all channels to facilitate use with third-party array sorters offline, which typically perform high-pass filtering to extract a continuous spike signal for waveform thresholding. Also, since field potentials from high-density probes are typically nearly identical between nearby sites, Plex Control defaults to record only one of every 8 field potential channels. So channels 1, 9, 17, etc., as shown in the chart on the right hand of the slide. The user has the ability to change the fraction of field potential channels to be recorded from the default 1:8 ratio. This functionality affords the user the ability to select on a per recording basis which types of data are recorded into the PL2 file and which channels are recorded into the PL2 file. It should be obvious, but it is possible to generate huge data files with OmniPlex, especially when acquiring data from SiNAPS probes. This new recording control functionality ensures reasonably sized files while still preserving valuable high frequency and low frequency data. Lastly, Plexon has developed a sophisticated way of processing PL2 data files acquired from SiNAPS probes with OmniPlex. For offline processing of collected data, SiNAPS and OmniPlex users benefit from the efficient PL2 file format, which enables significantly faster channel read time compared to other open source and commercially available file types. The PL2 file format is compatible with KiloSort, Spiking Circus, and other array sorting packages via Plexon SDKs and processing pipeline software developed specifically for Plexon for SiNAPS data. users can still use offline sorter, visualized in the OmniPlex online pathway on the left of the slide. However, offline sorter was developed well before array data was available and offers no array-specific sorting options likely valuable and needed by researchers acquiring SiNAPS data. Instead, the OmniPlex offline pathway on the right of the slide is likely to be more valuable to SiNAPS OmniPlex users, as it enables the use of Plexon PL2 files in offline, open source, array-specific sorters like KiloStore and Spiking Circus. More information about the offline data pipeline will be available soon. Additionally, be on the lookout for a forthcoming webinar specific to offline handling of data files acquired from SiNAPS probes with OmniPlex systems. In summary, these 4 software features, auto calibration, online spike culling, recording control, and the offline data pathway, are all new additions to the OmniPlex software suite specific to SiNAPS probe acquisition with OmniPlex. Lastly, the SiNAPS technology options available today from Plexon are just the tip of the iceberg. Today, an acute option with limited configurations is available, but that is just the beginning. In the near future, we will have a version of the probe suitable for use targeting deep structures in non-human primates. There will be a chronic version, including a commutator and microdrive for use in freely behaving animals. Also, different configurations and packages, including multiple shanks and higher channel counts, will be available soon from Plexon. Here are some high-level details of a soon-to-be available non-human primate version of the SiNAPS probe. There will be a 512 channel count SiNAPS probe with a long, robust stainless steel shank for penetrating deep into tissue and recording from head-fixed behaving non-human primates. The probe itself will feature a thin, flat tip, approximately 50 microns thick and 320 microns wide. Distal from the probe is a thicker stainless steel shaft, which will then connect to the SiNAPS head stage. Overall, the non-human primate version of the SiNAPS probe will be configurable in lengths up to 12 centimeters. Plexon will soon contact some of its existing non-human primate OmniPlex users for beta tester opportunities. Be on the lookout for the non-human primate SiNAPS probes from Plexon. I expect these probes to be popular. So, in summary, we've heard about 3 main details of SiNAPS probes and related OmniPlex technology. We heard about the new SiNAPS active CMOS-based electrodes available in 256, 512, and 1024 channel configurations. Importantly, the basics of the SiNAPS technology means acquisition with OmniPlex from all channels, not just a subset. We also heard about new OmniPlex hardware related to SiNAPS, including a new head stage, the new SiNAPS adapter, and new testing devices. Additionally, we discussed a new Plexon blue box required for use of SiNAPS probes with OmniPlex. Lastly, we heard about new software features dedicated to SiNAPS acquisition and visualizations in OmniPlex. These include online array culling, recording options to ensure reasonably sized data files, and an offline data pipeline for processing PL2 data files acquired from SiNAPS probes with OmniPlex. So with that, that's what I was hoping to talk about this morning. I appreciate your time and attention. Again, my name is Andrew Klein. I am Vice President of Sales and Marketing at Plexon. Please reach out to me with any questions you have about information shared here during today's webinar or about OmniPlex in general. I appreciate when users email me, so please do with your questions. If you still use Twitter, I can be found there. If you're cooler than Twitter, I am too. I can also be found on Bluesky. There are several ways to get in touch with me. Please do. With that, I will open the discussion for questions or comments. Nayoka, do we have any questions?
Yes, yeah. Thank you, Andrew. I will So as I mentioned, you can unmute and ask your question as well. So just if you want to use the raise your hand feature, you can do that on Zoom. But you can also put them in chat. So I have a couple in the chat already. I'll go ahead and read to you, Andrew. Can externally generated TTL pulses be collected for generating PSTH? Can external analog signals be collected to analyze behavioral signals?
Yeah, so that is a functionality of OmniPlex just in general, period. And for users of the OmniPlex platform, there's not a lot that has been removed for use with SiNAPS probes. It's mostly been additions. So if you're an existing OmniPlex user and are familiar with the digital input operations or the auxiliary analog inputs or any of the secondary features of OmniPlex, those all exist and are the same as they were yesterday, and they'll be the same tomorrow. This edition of SiNAPS is really just a change to the front end that's required for a novel active electrode.
Okay. Another question, someone says that the adapter that you showed looks like it can connect two head stages. How many probes can be attached to the system? What's the maximum number of channels?
It's a good question. So there are several different versions of the SiNAPS adapter, some with one connector, some with two connectors. Eventually, it'll be possible to connect multiple probes to the same SiNAPS adapter, and it will also be available to connect multiple SiNAPS adapters to the same system. So it really depends on the configuration. Other probe configurations or future probe configurations may have multiple connectors, but as it stands right now, the SiNAPS adapter can connect to one probe. That will soon change, but it's a one probe interface for right now.
Okay, and Sarang asked, what is the cost of the system for freely moving mice? And can you elaborate more on what is best practice to do when recording on freely moving mice?
So let me address the second part first. With freely recording mice, I think there's going to be some work to be done in two different ways. One is going to be some kind of commutator solution. The head stage and the SiNAPS adapter are large devices that would likely impede some kind of movement of a freely moving rodent. A commutator solution from Plexon will address the size of the SiNAPS and kind of what happens to that SiNAPS adapter when it's plugged into the commutator. Additionally, the head stage itself would have to be smaller. We have a version of that, and there will be a version that can interface with a microdrive, which is something that is commonly needed and commonly used with freely moving rodents, as you likely know. Specific to OmniPlex, there are several things that are valuable for freely moving rodent work. Some of the digital referencing functionality that has been built into OmniPlex and was released several versions ago is really valuable for recording from chronically implanted freely moving animals, especially with lots of channels like there would be with the SiNAPS probe. These are some functionality about common average referencing, common median referencing, selecting multiple channels, or selecting one channel as a reference for multiple channels, etc. You can get in touch with your typical point of reference or point of contact at Plexon, and they can describe some of that functionality more. Additionally, there was a webinar that Naoka and I did several years ago about OmniPlex that specifically addresses some of that functionality specific to recording from a chronically implanted, freely behaving rodent. In terms of cost, I don't really want to get into cost information here on the webinar, but that your point of contact at Plexon can talk to you about that. It's certainly the case that OmniPlex, the channel count that you can acquire from an OmniPlex system with SiNAPS probes is not going to scale linearly like it would with a common analog or digital head stage system that has been available in the past. It's just not affordable and not reasonable. So a a SiNAPS specific OmniPlex will be much more affordable than a more traditional OmniPlex that has been available for several years now. It's also possible to add functionality to an existing OmniPlex system. As we talked about earlier in one of the other questions, there's not a lot that's different about the OmniPlex system specific to its use and its operation. There's some hardware differences which can be resolved with an upgrade pathway, but if you have an OmniPlex system, it is possible to add that functionality, add SiNAPS functionality without removing the current functionality and without just buying a whole new system outright. So I guess that's as far as I really want to go about price, but we can have a conversation about that offline or at SFN, and I know you'll be at SFN, so that's something we can talk about there too.
Great. Okay, and I think in that you also answered one of the next questions was just if you could add this to an existing OmniPlex system, if that was possible or not. And I think you addressed that. Do you have anything else to say about adding it?
It's a common question, which I'm happy with. The goal here is to add this functionality to as many systems that are currently out there in the wild. As I said, there are hundreds of them, and so I would like to see hundreds of people adding SiNAPS to their existing OmniPlex systems. So that pathway is known and it's been tested, and there's no real issues with that. And as I said, it's not just buying a whole new system outright. It is possible to buy just a SiNAPS specific OmniPlex system. Those are quotes that we can generate for you today if you're interested, and we can talk about them at SFN. It's also the goal that any future development within the SiNAPS platform be compatible with the SiNAPS system that's available today. So I don't foresee any kind of big changes that will require additional or costly new hardware in the future that might support future SiNAPS development. That's at least my goal. That's what I hope for, but I think that should be attainable.
Okay. Can we stimulate through the probe?
Yeah, great question. As it is today, no, partly because it's an active probe, so you'd have to have some way of generating that stimulation current from the probe itself, but that is an option that is in development as it is right now. So one feature below the ocean surface there on this iceberg is the ability to stimulate through the recording channels or stimulate through dedicated stimulation sites. That's not something that will be available necessarily soon, as I would say, like a non-human primate version of the probe will be available much sooner. But electrical stimulation is certainly on our radar and something that is being developed.
All right, we have one in the chat says, what is the sampling frequency for each individual channel? There's a couple questions here, Andrew. So that's the first one. Is there any API or online toolbox to allow for closed loop control, or is everything presented here open loop?
Sorry, I was listening to the second question. I forgot what the first question was.
The first question is, what is the sampling frequency for each individual channel?
So everything with OmniPlex is at 40 kilohertz. So the data that's actually sampled from the probe is less, and then there's an upsampling that happens in OmniPlex. This is exactly the same thing or something similar to what happens with Intan head stages used with OmniPlex. But effectively, the data that will be acquired and the data that will be available in the PL2 file is 40 kilohertz. Plexon has always been 40 kilohertz. We could have a webinar on the answer to why that is if we wanted, but that's just the way it is. Plexon is 40 kilohertz. In terms of the API, that's a good question, and it kind of depends upon what you mean by closed loop, but the OmniPlex system as itself has an online SDK that allows for closed loop stimulation or closed loop applications. That's nothing new. That's been available probably since the very beginning with OmniPlex. I know it's been available with the DigiAmp system and the DHP systems. Anything that we've offered in the last 10 years has been closed loop possible. So I'm not really sure what open loop necessarily means, but doing something closed loop with the system is certainly possible. And there's nothing about SiNAPS use that really changes that functionality or breaks that functionality. that's a functionality specific to OmniPlex and not necessarily specific to the front end. So yes, there is an API for online closed loop experiments. That's something that we periodically talk with users about. It seems that those conversations kind of come in clusters. So maybe that'll be a busy fall for us with online SDK questions. But yeah, that SDK is available on our website. It's documented. There are some examples. We have lots of answers to questions that people have. Please contact us if you have questions or issues or ideas about how to use OmniPlex in some kind of closed loop way.
Okay, and then for now, there's only one more question. So if you have anything that you're thinking about, go ahead and put that in. But the last question that is in there right now is about SiNAPS. Can SiNAPS be used with the new system?
Great question. The answer to that is yes. So that's not really something that we've had a careful focus on right now, partly because the initial launch of this system is still a quite acute application. So there doesn't seem to be really a low-hanging fruit need for direct SiNAPS time-locked acquisition with OmniPlex when it's used with SiNAPS probes. That said, there's nothing specific about SiNAPS use that breaks the time-locked functionality of SiNAPS or any other really time-locked other third-party device or Plexon developed device like SiNAPS. SiNAPS is a system within Plexon that's still being actively developed, and we sell lots of OmniPlex systems with SiNAPS. Yeah, there's that when a version of the probe is available in a chronic package with a commutator that can be used with OmniPlex in a freely behaving animal setup, SiNAPS will also be one of the features of that system. I apologize for fumbling with my words. It's very difficult to keep SiNAPS and SiNAPS straight, so it's just something I'm going to have to get better with. But the answer is yes. SiNAPS can be used with a SiNAPS version of OmniPlex. There we go. I got it.
All right. All right. Well, thank you, Andrew. I don't see any other questions in the chat, but if you did have something that you didn't get a chance to ask, then you can just send us an email at info@plexon.com, or you can email either one of us or the sales team directly with your questions. And as Andrew mentioned a couple of times in the presentation, we will be at SFN. So I just put a slide up here so you can note the booth number. If you want to stop by, we'll have the system in the booth for you to put your hands on, see it working, and talk with the sales team about that. So please stop by and say hi if you'll be there. And thank you guys for joining us for the webinar today.
Yeah, thanks everybody.